All right, so today we're talking about real numbers. So real numbers is like a car manufacturer, like let's say Honda, okay? So real numbers like Honda. So under Honda, they make a bunch of different cars, like the Odyssey, the minivan, the Accord, which is their typical V6, and let's say the Civic, which is a slightly smaller car than the Accord. But no matter how we look at it, bottom line is that all three of those, when we see a Civic, when we see a Accord, when we see an Odyssey, we think of, hey, it's made all under Honda. It's a Honda, okay? So same idea here. So real numbers consist of several different things. So one of them is called a natural number. Okay, natural number, we also call these counting numbers. Well, counting numbers, we typically count how? We typically count it this way. 1, 2, 3, and so on. And these three dots just mean continues on, in this case, larger and larger and larger, or to the right, okay? And it also includes whole numbers. Where whole numbers. Whole number is just counting numbers, including the zero. So 0 and the counting numbers. So what does that look like? Well, that looks like 0, 1, 2, 3, and so on. Okay. And then there are also integers. Where integers. Integers are basically positive. How about if I do it this way? I'm going to write it out as positive and negative. And I'm going to tell you that we typically write it this way, plus or minus. Positive and negative whole numbers. So we got to include a negative side. So we're going to say dot, 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 coming from the left side, -3, -2, -1, 0, 1, 2, 3, dot, dot, dot. Okay? So those are considered integers, all right? And obviously that's the way you would draw your number lines, is using integers, all right? So we'll come back to that as well. What other numbers are there? Well, there's also rational numbers. Rational numbers are numbers that can be, well, how about if I put it this way? It's a number that ends or repeats. So, for example, 0.25, or let's even say 7.25, right? It ended. It's done. No more. Okay? That would be a rational number. A number that repeats. 0.3333, or we would have wrote it as 0.3 with a line over it, right? So that is also a number that either ends or it repeats. So I just showed you a number that ends and I showed you a number that repeats. Rational number also are numbers that are, so these numbers that ends or repeats, we can write it as a fraction. Okay, so essentially rational numbers are numbers that can be written as a fraction. So if you see a fraction, then you're talking about rational numbers. Okay. And obviously with rational numbers, there's also irrational numbers. Irrational numbers are numbers that don't end and don't repeat. Okay. Now, you're not going to address a whole lot of irrational numbers in this course. So, but I still want to introduce it to you because it is all part of the real numbers. Okay. So, irrational numbers, if you think about irrational person, an irrational person just keeps on ranting and ranting and ranting and ranting. And they might not repeat the same thing because once you kind of catch them on something, they're going to change the subject and then rant on that. And if you catch them on that, they'll change subjects again. So it's kind of like wheezing in and out of things, but they keep on going on. Okay, where a rational person, if you call them on it, they'll be like, okay, you're right, we're done with this argument, right? So examples of irrational number would be pi. Pi has not yet repeated and it has not yet ended. They're still looking for people to find the next digit for pi. Although it's like a million digits already as it is, so they're finding like the millionth and first digit for that, all right? Another example would be like square root of 2, okay? If you put square root of 2 in your calculator, if you're able to do that, you'll see that this number just goes on and on and on and on and does not repeat. Okay, so we really can't write them as fractions besides putting them over 1, but that's not a typical fraction that you would see. All right. So with that being said, let me go back to rational numbers. This 0.3 repeating, this is essentially 1/3. So if you put 1 divided by 3, you'll get 0.3 repeating. So remember what I said in the last lesson that fraction sign symbol is also known as division. All right. Okay. So what are some of the things you're going to see in here? Well, some of the things you're going to see in here is you're going to see like number lines. You're going to see a number line, and what you're going to see is you'll see that the center is 0. Everything to the right is going to be +1, +2, +3, +4, +5. And everything to the left is -1, -2, -3, -4, -5. Okay? So think of it as, the center is 0, and anything to the right of it. So everything to the right of it. So let me do this here. So here's my 0, okay? And everything to the right, why am I doing that when I can do this? Everything to the right is going to be known as greater than 0. Okay? And then everything to the left is going to be less than 0. Okay? And you're wondering what the symbols are, right? So if you look at the less than sign, this is the less than sign here, okay? If you kind of look at it as an angle, you'll see it looks like an L laying down, like 3D model wise, right? If you have like one of those letters that can stand up on your bookshelf and you knock it down, that's what that L would look like. So this is the symbol for less than. Okay? So everything to the left of 0 will be less than 0, which makes sense because anything less than 0 is going to be negative. And then this symbol here doesn't look like an L that falls over the correct way, at least. I guess you can always make a case for it, but this would be a greater than sign. okay? And we'll learn about more inequality type stuff, but essentially the category that this is going to be under will be inequality. Again, inequality versus is not the same as irrational, okay? So don't mix those two up. All right, so, and the thing that you gotta understand is that I would say that think of this as money, and that's why I had it in black and red, is because usually, you know, when they talk business, they always talk about how we're in the red. If you're in the red, then that's no good because that means you're in debt, okay? So if you think of money, then you can say, okay, I know that if I am indebted of $5, if I'm in debt for $5, or I have a loan up for $5, I have less money than if someone had a debt of $1, right? So, and then I know that you guys have talked about before where, you know, this symbol here is like a fish, right? Wow, that's an awful fish. Okay, it's like a fish, right? Or Pac-Man or whatever. And this is going to eat the larger number. I agree with that. So I'm okay with you think of it that way. So if we think about this right here, what is it eating? It's eating the -1. Is -1 the larger number versus -5? Okay. So again, think of money. If I'm $5 in debt, do I have less money than someone else that is only $1 in debt? And I am. I definitely have less money. So being $1 in debt is definitely the larger number. Okay. You can say that that you know that $2. If I have $2 in my pocket, I definitely have more money than someone that is $1 in debt as well. Okay. So I want you guys to think of it this way. Now, doesn't matter. It doesn't matter if you wrote it this way or you wrote it this way. This means the same thing. And this means the same thing. Okay? Just because the numbers flip sides, if you notice, it just looks like the total mirror image of it. Okay? So you can give me either answer, you still be right. And if you look at the symbols, it's still eating the bigger number in both examples there. Okay? And then the other thing is that if you look at it, if they give you examples like, you know, it's 5 degrees below 0, right? If the temperature was that way, I know here in Florida we don't experience that. But if it's 5 degrees below 0, then we would represent that as -5 degrees, right? So that's what you got to think about. If you think about bank accounts, right? If we think about withdrawals, right? Withdrawals is taking money out, so that'd be negative, while a deposit would be adding money in, so that would be a positive, okay? All right, what else are we going to see? So number 1, you're gonna have to be able to do that. Number 2, let's say that you're given a slew of numbers, right? Let's say, for example, you're given 2/3, -2/3, 7, 4, -3, 0, 23/8, -8, 2.4, and -0.17. Okay, so the question is, you know, how can I put this in order? Oops, I'm sorry, fix that in a bit. Okay. Put this back up here. All right. So how can I put this in order? So what I'm going to tell you that you should do is to actually put these in fraction form if they are a fraction. Sorry, they are in fraction form. So we're going to make them to decimals. All right. So for example, 2/3. Okay. I can make this a decimal by putting into my calculator as 2 divided by 3. And I should get a number like 0.67, or you know what? Let's do it this way. Let's say 0.6 repeating. Wow, that's awful. Okay, so then that means the negative 2/3 is going to be negative 0.6 repeating. We know that this is going to stay 7 and 4 and negative 3 and 0. What is 23 divided by negative 8? So 23 divided by negative 8 is going to be, so let me do this here, lasso, take this, and let's pick blue, okay? And this is going to be a negative 2.875, okay? And then we have the 2.4 and negative 0.17, okay? So what would I do? So this is what I would do. I would take all the negative numbers. So I know the center is going to be 0. That's my center, okay? So everything to the right would be positive, everything to the left would be negative, all right? So what I want to do is I want to put everything that's negative on the 0 side, everything positive on the right of the 0 side, okay? So let me see here. I have a negative 0.6 repeating. I have a negative 3. I have a negative 2.875. And I have a negative 0.17. Okay. So what's on the right side? The right side, I have a 7. I have a 4. I have a 0, which is already there. And I have a 2.4. Let's see, 2, 4, 6, 8, 9 numbers. 1, 2, 3, 4, 5, 6, 7, 8. So I'm missing something. Oh, got it. The 0.6 repeating. So notice what I did. I also counted the number of numbers there were and make sure that I have them all. So this way I don't miss any. So if I had to put this in order, well, let's put the negative side in order first, right? Remember that, think of money. If I'm more in debt, that means I am a smaller amount. So in this case, it's going to be negative 3. And then it's going to be the negative 2.875. And then it's going to be the negative 0.6 repeating. And then it will be the negative 0.17. And then it's going to be the 0, right? So I got the 4 numbers and then the 0, which should be my center. So let's take this and move this to my center. So I got that right there. So now let's do the right side. So if I do the right side, which is the positive numbers, let's put that, okay? So if you think of money, whoever has more money would be further to the right. Whoever has less money will be closer and closer to not having money. So in this case, the one that's closest to 0 is going to be a 0.6 repeating. And then is going to be my 2.4, and then the 4, and then the 7. Okay, so notice how I broke this down. I did it bits and pieces here. All right, so now let's look at the left side again. Okay, so the left side, if I look at that, because I was given in the original some fractions. So that means I have to give the answer back in fractions. And the ones in fraction was the one in red, the green, and the blue. Okay, everything else was black that was given as either decimals or integers. All right, so I have to make sure I change the blue, the green, and the red back into my fractions. Okay, so I have a -3, comma, 23 over -8. In fact, I'm gonna change this back to navy blue. All right, and then I have, this was -2/3, then -0.17, then 0, then 2/3, then 2.4, 4, and 7. So now this right here would be my so-called answer if I was to put these numbers right here in order. All right. And then I still need to talk about absolute values. Okay, so let's talk about absolute values. So number one, absolute value has a symbol like this. It's like two big bars on the side, okay? And that is just the distance. The definition of that is the distance from 0. So if your mom was saying, hey, where are you going? You're about to go out the door. Where are you going? Oh, I'm going to a friend's house. And she goes, where's your friend's house? You're going to say, oh, it's just a couple doors down. You're not going to say, well, it's -2 doors down, because you're going to turn left. And if you're turning right, you're like, it's positive 2 doors down, right? You're just going to say it's 2 doors down. You're not specifying in general which direction, so you don't really need to put that in. So it's just a distance. So in other words, after you take the absolute value of something, it's going to be positive. So for example, let's make a number line here. Okay. And let's set 0 here in the middle. Okay, so if I said the absolute value of -5, oops, I always do this, of -5, well, how far is -5 from 0? You're gonna say, well, there's 5 spaces. So there you go. Well, if I said the absolute value of 5, well, how far is 5 away from 0? Still 5, okay? How far is absolute value of -3? How far is -3 away from 0? 3 spaces, okay? Now, you're like, well, that's pretty easy. We just take the inside number, just make it positive, and we go. You're right. However, the end result, meaning this part right here, the end result can still come out to be negative, right? And you're like, well, how? Well, what if I did this? The absolute value of negative of the absolute value of -3. Well, what this is telling you to do is this. is to do this first. So it's kind of like a parentheses. So if I did that, what would I get? I would get 3. Great. That's the green part. But the outside of it, so I'm going to make this, let's make it red. Let's see what that looks like. That tells me to now negate that 3. Okay? Or, you know what? Let's undo and make it red as well. So that's going to tell me to negate the 3, so therefore I have a negative 3. Okay? So there are things that will make the end result a possible negative. All right? But when you just take the absolute value itself, if you just take the absolute value itself, yes, that will become a positive number. However, if there's other things that come into play, then it could make the end result a negative. Okay, so you just gotta be careful of what you're doing. All right? And I hope that answers all your questions. If you do have any questions, you know how to get a hold of me.